All right, so let's check out this warm-up. First one, y equals 2/3 x plus 6. We are solving for x. So we would add 6 to both sides, yes? So we would have y plus 6 equals 2/3 x. Then what would you do?
Multiply by the reciprocal.
Good, multiply by 3/2. So 3/2 times y plus 6 is equal to x. We could distribute that and get that x is equal to 3/2 y plus, if we multiply 3/2 times 6, 3 times 6 is 18, divided by 2 is 9. Okay, look at number 2. Y equals 2 over x plus 5. The first thing I would do here is multiply both sides by my denominator. So I kind of think of this as being in parentheses. And then if I multiply both sides, I'm going to have y times x plus 5 is equal to 2. Now don't distribute that. If you distribute that, it gets really tricky. Okay, think about like we're kind of cross multiplying here, right? Y times x plus 5 and 2 times 1. Okay, now we're trying to solve for x. So how could I get rid of the y?
Divide by y.
Yeah. So now I have that x plus 5 is equal to 2 over y. And what is all I have left to do? Subtract 5. So x is equal to 2 over y minus 5. Looks kind of weird, but that's okay. Algebraically, it's correct. All right, look at 3. What are you going to do first, you think?
Square root both sides.
Okay, and when you square root both sides, you've got the square root of y is equal to x plus 2. And remember I told you that there's this plus or minus hidden out there when you take the square root? Don't worry too much if you forgot that. Not a big deal. Okay? Then what would I do? Subtract 2. So,
And only y under the square root.
yes, correct. Okay, on number 4, you had y equals the square root of x plus 10. What are you going to do first?
Square.
All right, so y squared equals x plus 10. Then what? Y squared minus 10 equals x. Alrighty. Oh, sorry. Dusting off the cobwebs. Exactly. Okay, so today we're going to talk a little bit more about inverses. Okay, so look at that graph on your paper. Gotta keep going. Sorry. I can give you a copy of it later. Okay, look at this graph. Is this graph a function?
No. Yes.
Come on, guys.
No.
It's not a straight line, is it?
It's not a straight line. It's a curve.
So it's yes.
Yes. It looks like, I guess if that's what's catching you up, then that's okay. It looks like it might be getting straight, but this is like a really exaggerated cubic curve. Okay, so this graph is a function. How do we know?
Because it passes VLT.
Passes the vertical line test, which means if I draw vertical lines, it only passes everywhere once. What does the passes the vertical line test means? It means that same thing as we've been saying. Every x value can only have one y value. Every x value can only have one y value. Okay, let's think about inverses here. Would you agree that I could say this is a point at like 0, 5, and this is a point at like 3, 5? Would you be okay with that? If I wrote to graph the inverse, okay, what are 2 points that you could tell me are going to be on that inverse? If this was 0, 5, 5, 0, and if this was 3, 5, 5, 3. So 5, 0, and 5, 3. Those are now 2 x values that have what? Two x values of 5 that have different y values, right? So what that means is anytime you are thinking about the inverse of a function, if they had two of the same y values, then when you take the inverse, they're now going to have two of the same x values, right? Because we flipped x and y, okay? So instead of using a vertical line test to tell if the function, the original is a function, we use what's called the horizontal line test to tell if the inverse is a function. Because do you see that this fails the horizontal line test? So that tells us that the inverse of this graph is not a function. Okay? So we use the vertical line test for the original. We use the horizontal line test to tell if the inverse is a function. So the horizontal line test says if a horizontal line crosses the original function, or the original graph, more than once at any point, then we know that the inverse is not a function. Does the horizontal line test tell us anything about the original? No. It only tells us about the inverse. Everyone okay with that? Okay. Number 3 says, do the following graphs have an inverse that is a function? So are they asking us right now about the original? No. But these are the originals. We're using them to tell us if the inverse is a function. So look at the first one. Is the inverse of this absolute value graph a function? No. Why not? It does not pass horizontal line test. So the inverse is not a function. Is the original a function? Yeah. All right, look at the next one. This right here is an implied, what's called an asymptote, where it approaches and gets closer and closer and closer and closer, but it never cuts it. So this does not turn into a straight line. This is still curving down gradually as it goes on. So does this pass the horizontal line test? Yes. Okay, look at this one. Does that pass the horizontal line test? Yeah. So is the inverse a function? Is the original a function? No. So we've now seen that the original can be a function and have an inverse that is not. Or the original cannot be a function but have an inverse that is. Both are accepted. We call something a one-to-one function if both the original and the inverse are functions. Okay, so one-to-one means that both the original and the inverse are functions. Meaning it has to pass both tests, right? It has to pass horizontal line test and vertical line test. Okay, so using that definition, we now want to be able to tell if the graphs below are one-to-one, meaning that they start as a function and that the inverse is a function. So let's look at number 4. Look at that first one. Let's start with the original. Is the original a function? Yes. Is the inverse a function? No. Why not? Good. It doesn't pass the horizontal line test. So this is not a one-to-one function. Okay, try the next two. Okay, what about the next one? One-to-one? Yes. Yeah, again, that's that weird asymptote thingy. So they're not, that one's kind of hard to see. This is going to keep approaching 0 this way, and it's going to keep approaching 0 this way, so they're never going to cross. Again, sorry, this is a hard graph. I should have talked through this one with you. There's a vertical asymptote here as well. So they approach a vertical line as well. This is what's called a rational function, which we'll study next semester. Sorry, I should have talked about that one with you guys.
What's an asymptote?
Asymptote is like a boundary. Do you remember learning exponential functions where it got closer and closer to 0, but it never hit it? Okay. All right, what about this parabola? One-to-one? Okay. All right, look at number 5. Remind me how we find the inverse algebraically. Tell me about our steps.
You first switch x to y,
Okay,
and then you switch x and y.
good.
And then you solve for the new y, and then you put f -1 in parentheses x equals, and then what?
Very good. So we switch x and y, and we solve for our new y, or the main steps, right? With the changing of our notation at the beginning and the end. Okay, so we're going to solve a couple of these. I'm watching my time so we can make sure I get to the word problems. Okay, I'm going to go ahead and skip 6 and... yeah. I'm going to skip to 8. 6 and 7 look a lot like the ones we did yesterday, and I'm confident you guys are okay. If you're not, come see me, and we'll do them. Okay, let's look at number 8. It says f of x is equal to x squared over 3, where x is greater than or equal to 0. The only reason this x greater than or equal to 0 thing is here is so that when we find the inverse, we will still be not breaking any math laws. Okay, and I'll show you why in just a minute. This is just a domain restriction, so don't worry about that right now. Our function is this, x squared over 3. Okay, so I switch x and y, so I make this be x equals y squared over 3. Is everyone okay if I don't do it the extra step for changing it to y? Cool. Okay, then what would we do?
Multiply by 3.
Multiply by 3, so I would get 3x equals y squared. And then what do I have to do? Square root. And when you take the square root, and we'll talk about this more later, but now just memorize it as a rule. When you write in the square root yourself, you're going to put that plus or minus thing in front. Now, the reason this thing was here, x greater than or equal to 0, is because if that wasn't there, then we would have some values of this inverse that were undefined. Because I can't take the square root of 3 times -7. Right?
Do we just solve for y?
I switched x and y in the first step.
Oh.
Okay? So I would rewrite this as f inverse of x is equal to plus or minus the square root of 3x. We're okay with that? Okay, look at number 9. What should I do first? Good, switch x and y. All right, go for it. We're doing 9. Sorry, I'm just making it bigger so I can have more space. So I'm going to make this x equals 5 plus the square root of y plus 2. Okay, what do we do first here? Subtract 5. x minus 5 equals the square root of y plus 2. What do you think we do next? Square. Now, do I square each of these individually? No, I square it like it's stuck together, like a binomial. So this is going to become x minus 5 in parentheses squared equals y plus 2. You do not have to multiply that out.
Why?
Why what?
Why do you not have to go with x squared times?
Because you're not squaring these individually, you're squaring the whole thing. So if you were to multiply this out, you have to double distribute. You would have to do x minus 5 times x minus 5.
Oh, yeah.
Okay? All right, then what would I do? Subtract 2. And then change it to f inverse of x. So the only new thing I'm really asking you to do is switch the x and the y. Everything else right now with these inverses is just some challenging pieces of algebraic solving. All right, let's look at 10. Switch my x and my y. So it becomes x equals 3 times y plus 2 squared. All right, what do I have to do first? Yeah, got to divide by 3 first. You can't take the square root until you've isolated whatever's being squared. So this is going to become x over 3 equals y plus 2 squared. Okay, then what?
Square root.
Good. When you write in the square root, you remember to put in?
Plus and minus. Good.
All right, we'll practice it a lot this year. And then our last step, subtract 2. So that would mean that f inverse of x is equal to, you can do negative 2 plus or minus x, the square root of x over 3, or you can do this minus 2. It's up to you. Okay, let's try number 11. This one is challenging you to really remember your algebraic steps, your order. Order of operations, if you will. Technically reverse PEMDAS at this point. Okay, we switched our x and our y's. What do we do first? Multiply by 3. Good. So that, oh, thank you, thank you. Okay, so now multiply both sides by 3. So I have 3x equals 5 plus the square root of 10 minus 2y. Good. Then we subtract 5. So 3x minus 5 equals the square root of 10 minus 2y. Square both sides. And what do I have to do with that 3x minus 5? Parentheses, good. 3x minus 5 squared equals 10 minus 2y. Good. Minus 10 would be our next step. Minus 10, so I have 3x minus 5, the quantity squared, that's all minus 10, is equal to what? Negative 2y. Good. The last step would be to divide by negative 2.
Can you leave that like that?
For the most part, you can leave it this way. I don't normally leave a negative in the denominator because it's kind of weird. So I would also think about writing this as the opposite of 3x minus 5 squared plus 10 over positive 2. But that's not required. I just think it's kind of weird to leave a negative in the denominator. You would not lose credit if you did that. Unless it were negative 1. You can't leave negative 1 in the denominator. Okay, so these are a little more challenging. You'll get some practice with those tonight. Let's talk a little bit about application problems with inverses. Yeah.
So because the 3x minus 5 is in parentheses, that the negative, like, opposite doesn't apply to it.
So what you would do with order of operations is you would square the 3x minus 5 first, then you would multiply and distribute the negative. Okay? Okay, application problems work differently for inverses. You do not follow the same steps, so please make sure you take good notes on this problem so that you don't get confused. So if you follow the same steps, things get weird. And because we're dealing with real world examples, the inverse means something a little bit different. Okay, so here we are. We are given a, let's see, a can for sports drink. And we're given the formula for the lateral surface area. Okay, this right here, this means L of H. So we mean that as the lateral area as a function of H, meaning you're going to plug in H and you're going to get out the lateral area. Everyone okay with what that means? Okay. So our independent variable here is H, right? That's what we plug in. And what we get out is the lateral area. Okay. So the inverse then means we basically switch the independent and the dependent variable. Because that's really what an inverse is. It switches independent and dependent. Okay? So instead of the lateral area depending on the height, what are we going to have? Good. We're going to have the height depending on the lateral area. So another way you can say that is the inverse is going to be the height in terms of the lateral area, which looks like this, H of L, a function of the height in terms of the lateral area. So you see we're only switching what we're solving for. Okay, so, whoa, all right, that's fun. Okay, so what we're going to do to find the height, to find the inverse, H of L, to find the height depending on the lateral area, all we're going to do, and I would jot this down so that you remember, is you are going to solve for the other variable. So we start with the lateral area is equal to 2.5 pi h. But I want to solve for the height, so that the height will be in terms of the lateral area. So what do I divide by? 2.5 what? Pi. So what that means is my inverse, or h of L, is equal to the lateral area divided by 2.5 pi. Do you see how now it's h in terms of L? You plug in L and you get out h. Okay, so it's different for application problems. Now, a quick hint that will come up a couple times this year. Say we had time to get out our calculators and do C, where they gave us the lateral surface area of 35.34. Where would we plug that in? Gives us the lateral area, so we're going to plug it in for L, right? And we want to find h, so we would use our calculators and we would divide by 2.55. Now, if you forget to put 2.5 pi in parentheses to divide by the whole thing, your calculator will divide by 2.5 and then multiply by pi. So you've got, that's just a friendly hint. When you go back to using your calculator sometimes, that has to be in parentheses when you put it in the calculator. Okay? On your homework tonight, use your reasoning skills. If it is a question that is asking you to plug things in, divide by 2.5, things like that, use your calculator. If it is a problem that is just finding the inverse, do not use your calculator. Okay? Make sure you look closely at your homework assignment. Number 12 through 16 tell you do not need to do the range for the inverse, just the domain. Okay? Okay. Your homework is on your timeline and it is out of the book.